Okay, we're going to be talking about variables today. Most programs work by accepting some sort of data from the outside and processing or manipulating that data in some way that makes it useful, then spitting it back out as information to the user of the program. When the program is accepting the data, it's called input, and it stores it in its memory so that it can use it later during the processing time. The data is stored in a specific location in memory, so when the data is needed, it can be retrieved from that same spot in memory. For example, say you get the weekly sales figures from a database or as input from the user. This information is going in. These numbers could be very different every time they run the program because each week the weekly sales figures might change. All the code that refers to these weekly sales figures in the processing needs to be generic, or will refer to them by name, not the actual value they entered, because each time it runs it could have different numbers to process for that week. When the processing is done on the data, then the information comes out called output, and it could be a report or a graph or bonus pay, etc. But while the data is being used in the program while it's processing, those values will be stored in these same spots in the computer's memory to hold all this data so that our code can run the same every time, even if those values that come in are different each time it runs. Now this will probably make more sense as we start coding and things, but that's kind of how it's working with variables. We will store and retrieve this data by referring to a word that will describe the spot in memory that holds that data. A name is easier to remember and more meaningful than if we were trying to remember a memory address location in our storage. So when we need to retrieve the data to process it in code, it's easier to remember that name. When the program lets you store the data in a place you can name, it's called a variable. So I might have a variable called name, as you see here, and that stores the values that the user gives me maybe when they start the program. It stores our name. So name would store the value of Julie in my case. I might have a variable called score that stores the current score, or a variable with the name counter that holds a number. As the program runs, the values inside the variable names can change, but the variable name will always remain the same. Sort of like a mailbox. So your postman knows our address, and that relates to our mailbox. And the mail inside the mailbox may change, but our address remains the same. So it's storing different things. The different data can be stored in the same variable, but the variable name will remain the same. Data as inputs and data that has been manipulated or calculated can be stored in these variables, and the data inside the variables can change as this is happening. Okay, for example, if I had a program that asked for the user to type in their name, the text that the user types in might be stored in a variable called your name. Then later, I could come back and greet the user by name by finding out what data type or data text or value was stored in that variable called your name. I just have to use the variable's name, and the value that is stored inside of it will be available to me. Next time, a different user might run the program and put their name in as input, and this program code and variable name could all remain the same. It would still work for that user as well with the your name variable. You should also use very descriptive names for your variables to keep them from getting confusing as you code. You also want to make sure you pay attention to upper and lower case. Some programs are case sensitive, which means if you use a capital letter, you must refer to it with the same case for the program to recognize it later. If you use name, as we see here on the top, as the variable, but later you refer to it as name with a capital N, it won't recognize it. Also, a good practice is to use camel case. If you have two words together, the first word is in all lowercase, and the other words after that have initial caps. So we'd have first all in under lowercase and then capital N for name. Some programs might use an underscore between words, like first underscore name. But whatever you use, be consistent and stick with the way that you name your variables throughout your code. Some programming languages also need you to let them know what type of data will be stored in the variable. For example, will it be a number or will it be text, letters or characters that are stored in it? If the programming language cares what type of data is stored in the variable, it's called a strongly typed language. So for these types of programming languages, text like a user's name would be called a string or char, C-H-A-R, for character. Whole numbers like someone's age would be an integer or int, I-N-T. And amounts of money and things like that would be maybe a double or a float. Difference there being that float has 7 decimal points of precision and double has 15 decimal points of precision, but that takes more resources and more bits of space to save that information. But some languages, like JavaScript, will let you store any type of data in the variable. So you could actually switch from the same variable having text to later having a number in it and use that same variable. So JavaScript would be referred to as a weakly typed language. So here are some examples of different languages creating a variable named salary and assigning it a value of 45,000. So the different languages with the different ways that they'll do that. Creating a variable is called declaring it, and here the variables are getting declared and at the same time getting a value put into them. So we have Liberty Basic, and it's got salary =, 45,000. Visual Basic dim, keyword, salary as double =, 45,000. Revolution is put 45,000 into salary. JavaScript var salary =, 45,000 semicolon. Java double salary = 45,000 semicolon. C++ double salary =, 45,000. Swift var salary double = 45,000. Now Swift is a strongly typed language, but it can infer that you're putting something into it without, if I had left the colon double off there, it would have inferred that salary was an integer. So just be aware there. We'll see that in code here in just a minute. I like to read the ones with the equal sign as 45,000 is assigned to salary, not salary equals 45,000. We're taking on what's on the right and placing it into the variable on the left. All right, you don't have to put a value in the variable that you're declaring. You can set it up. You can set up that location in memory for the data that we know that will be coming later, like an empty mailbox. Is anticipating that we're going to be getting mail coming into it later. We just don't have anything in it now. I'm going to show you the same thing in a number of different languages again, but this time we're going to just declare it or set it up, the variable, and leave it blank or null, and it would later be available to have the value or data stored into it. So here's Java. Here we have double salary, and that's setting up the variable, and we know it's going to have a double, so Java is a strongly typed language. And then later in code, the second line would happen somewhere down the line. Once they have input from somebody or get something from a database, maybe it will put this value and assign it into salary later. Okay, here's an integer being set up all by itself. Int my number it's just empty or null. Later, then they could assign the value into 50 into my number. Let's look at it in some other languages. Here's C++, double salary to declare it. Later, you can assign $45,000 in, or 45,000, I shouldn't say dollars, into salary, int my number, and assigning 50 into my number. Again, you can see C++ is a strictly typed language because it did have to require what type of data was going in. JavaScript, weakly typed. We don't have to tell it what kind of data is coming in. We can just say var for variable, var salary, and then later in code we could then assign the value to it. Var my number, later assign the number to it. Swift is strongly typed, so we say var salary colon double. Later we can assign to it, and var my number int for integer, and then later assign 50 to that. Okay, so let's talk about the inference. So you can see that some of them you have to put the data type like int or double. But with certain languages like Apple Swift, which is strongly typed, it looks like you're declaring the variable with a string value and you're not stating the data type. Oh, sorry, hold on. So let's take a look at this. Var street, and it's getting assigned in quotation marks 9th Avenue. Swift is using type inference to implicitly set the data type of the data stored in the variable street to string because of the data that you assign to it. It sees the value going into street is a string, so it is assuming you want the data type for street to be string. But if you wanted to set up the variable street without any data, you'd need to let Swift know what type of data will be stored in it later. So if we didn't, right when we were declaring it, we didn't know it was 9th Avenue, we would have to say var street to set it up. String, expecting string, string data to go into it. It's empty right now, but later we're expecting some sort of string to go into it. We would have to let it know. Here you're setting up a blank or null variable, but you know that later you can assign a value to it, and it has to be string data type. Okay. Then later, you could put Main Street and assign that into street. But if you tried to assign 50, which is an integer, into street, you would get an error with this line. Because originally you set up this variable street to accept strings, not numbers. However, this last line, 50 inside parentheses, would actually, or not parentheses, quotation marks, would actually work because the 5 and the 0 are seen as two characters or text, not a number. Anything in quotes, they assume it's a string or letters or characters, so that one would actually work. So just be aware of how the programming language that you use will handle these variables. Okay, now that you know how to set up the variables, with some languages, you also know how to set up the type of data that it can hold to be aware as the code runs. The value assigned to the variables can change as long as it remains the same data type for some of the languages. You can assign the variable salary the value of 45,000 and then later assign the same variable a different value of 60,000. So now the variable called salary will hold 60,000, not 45,000. You could use that variable in other calculations and refer to it by name, and it will work as if the value that it holds was being used. For example, we have var salary and equal sign 45,000. So we're assigning 45,000 to salary. It's assuming it's an integer, inference there. Okay, and then the next line you see we have another new variable called raise being set up, but we're using some math there. A 0.03 times salary. So it's really going to be taking 0.03 and timesing it by 45,000. Then at the last line there is just saying print. This is your new annual pay plus, and then we're using both those variables again. But it's really going to be taking the values in both of those. One now has like 1,350 in it, raise does, and then salary still had the original 45,000. You add those together, and then your printout is going to say this is your new annual pay, 46,350. So you're storing the value of, let's go through the line by line here. You're storing the value of 45,000 in the variable called salary. The next line you're declaring a new variable called raise. The value you store there is the value assigned to salary, 45,000 times 3%. So when you're referencing a variable name, it will automatically assume you want the value that's stored in the variable to have the math done on it. Then the last line prints out some text, and then the value of raise, which was 1,350, plus the value of salary, 45,000. So you're using variables, but it's referring to the values in the variables to do that addition. So the output looks like this is your new annual pay, and then 45,350. Be aware that this code would be fine in a weakly typed language like JavaScript, but Swift would have a hard time with you doing multiplication on an integer and a double together. If this were Swift code, the same salary variable would use inference or assume salary is an integer. So when you multiply an integer and a decimal, the 0.03, or double or float like the 0.03 would be, then you would get an error on that. To avoid this problem, you would let Swift know that the salary was a double to begin with, like this at the top one here. Var salary : double, and then equal sign 45,000. Or you could also come down here and while you were doing the math, you could put the double in front of salary to change it to double before the math was done. So either one of those would work. Okay, if you know a value will not ever change as your program's running, you can assign it to a constant instead of a variable. As the name suggests, the value stays constant, and with variables, the value can vary or change as the program runs. For example, you know that raises will always be 3%, and that is fixed and will not change. You would create a constant with the value of 0.03, and it can be used in code like a variable, but you cannot change the value throughout the code. It is fixed. You might ask then, why not just use the number 0.03 and not a name at all? It's mainly to give it a descriptive name like raise or interest so that you can use it later in code. It's easier to understand, and there's less chance of using the wrong number in code. And if later you decide to change the program to give everybody 4% raises, you would only have to change it in the one line of code where the constant was given a value, and not all the other many places that you might have used it in code. But you can change the value of a constant when you're writing the code, but remember the value of a constant can't change while the program is running. All right, so that's variables and constants.